So basically this is just a way to get you introduced to exponent rules without me standing up here and say this is what the rule is, memorize it. So if we're looking like at the first part, we had 2 to the third, and then they wrote 2 3 times. Why do you think they did that? 2 times 2, that's what that exponent of 3 means, right? So then when you're handling that 2 to the fourth, how many times do they write it? So how many 2's did we have all together there? 7. So what do you think is like our shortcut rule? Have you found it yet? Just add your exponents. So if you're multiplying in terms of like bases, you just add your exponents. That's all that's going on. So if we were going to do the shortcut way for the next one, you've got 3 to the fourth times 3 to the first. So you're going to keep that base of 3, and then we said you just add your exponents, right? So what is 4 plus 1? 5. Now if we did that the long way, we're still going to arrive at the same answer. So if you've got 3 to the fourth, how many times do we have to write 3 out? 4 times. So 3 times 3 times 3 times 3. Then we've got times 3 to the first. So how many times do you write it then? Just once. And how many 3's do we have? 5, which is why we wrote 3 to the fifth. Is that okay? Does that make sense? Do you have questions about where any of that stuff came from? So is it alright if we just do the shortcut rules for the rest of these? Okay, so if we have 5 to the fourth times 5 to the fifth, what's that going to be? Add your exponents, so 4 plus 5 gives you 9. Looking at the next one, we've got bases 7 on both, so we're going to keep that. Then your exponent, we've got 2 and then 6. So what is 2 plus 6? 8. So that's just 7 to the 8th. Now again, if we like expanded those first and you wrote it out however many times it says to by the exponent, you would still end up at the same answer. Is that okay? Any questions so far? So how are we going to handle this last one? What do you think? We can't really like write it out m number of times because we don't know what m is, right? Can we write it out n number of times? Do we know what n is? No. So what was our rule? What did we say you do with your exponents? So could we say that this is just going to be x to the m plus n? That's your rule there. Is that okay? So like this is the one that we need to know. So I would maybe highlight that one. So if you're multiplying terms with like bases, you're going to add your exponents. So looking at the next one, they've got 2 to the third squared. Now when you square something, what does that mean? Multiply by itself. So that's why they wrote 2 to the third twice. Yeah? Now we know from before, if you've got same bases and you're multiplying, what do you do with your exponents? Add them. So 3 plus 3 gave us. So that's how they did that one. Is that okay? So let's try the next one. So we've got 3 to the fourth to the third. So how many times do we need to read or to write out 3 to the fourth? 3 times. So we'll have 3 to the fourth times 3 to the fourth times 3 to the fourth. Do you think our rule from before, where we just add all these exponents, is still going to work? Yeah. So what is 4 plus 4? Plus 4 more. So that's like 3 to the 12th. Have we found a shortcut rule yet? So if we go straight from here to here, you got 3 to the fourth to the third. So 4 times 3 gives you, and then up the one before, if we had 2 times 3, well, you get 6. So if it's a power to a power, you're just going to multiply. Now I'm really cheesy and like I like to come up with things to help y'all remember stuff. So I'm always like, if it's a power to a power, you multiply. So I'm going to make y'all do that in a minute, so just get ready, okay? So if it's a power to a power, you're going to multiply. So you're going to keep that base of 5. And what is 2 to the fifth? 10. Is that okay? All right, so looking at the next one. We've got 7 to the 6th squared. So again, a power to a power, you multiply. So that's going to be 7 with the exponent of, what, 6 times 2? 12. So the last part, we've got that m and n again. M and n. Those are really hard to say. How are we going to write that? How can we write a rule for that? You got an x to the m times n. Now I'm just going to put m, n together, because when they're touching like that, that's what it means, multiplication. So I'm going to highlight that again. So this is like our rule. Anytime you've got a power to a power, what do? If you don't remember, I'm going to make you do it. If you got a power to a power, you multiply. Get ready. It's coming. All right, so the next part is talking about quotient rules. So that's like dividing. So they had 2 to the 8th. So how many times did they write out 2? 8 times. On the bottom, they had 2 to the 3rd. So how many times did they write out 2 then? 3. Now, if we have 2 divided by 2, what do you get? What's 2 divided by 2? Cancels. It's like 1, right? So these could cancel. Then we could cancel another set of 2's and one more set of 2. How many 5's were, or how many 2's were left? 5, and they were on top, which is why we did 2 to the 5th. Is that okay? So let's try the next one. So you've got 3 to the 5th on top. So how many times are we going to write that out? 5 times. So 3 times 3 times 3 times 3 times 3. And then on the bottom, what do we have? 3 to the 3rd. How many times do you write 3 out this time? 3 times. So 1, 2, 3. And then we'll cancel what we can. So we could cancel those 3's and those 3's and those 3's. What are we left with? 2 3's, and they're on top, so that'd be like 3 squared. Is that okay? Alright, so let's look at the next one. So we've got 5 to the 6th on top. So how many 5's are we writing on our numerator? 6 of them. And then on the bottom, how many 5's do we need to write? 7. So then we're going to start canceling, yeah? So those cancel, those cancel, those cancel. And what are we left with? We have 1 5, and where is it? The bottom. So that'd be like 1 over 5. Is that okay? So for the next one, we've got 2 to the 4th on top. So how many times do we write out 2? So 2 times 2 times 2 times 2. On the bottom, what do we have? 4 2's again, because it's 2 to the 4th. So 2 times 2 times 2 times 2. And we'll cancel what we can. So those go away, those go away, those go away, those go away. What are we left with? If everything cancels out, what is that? What's like 2 divided by 2? 1. So if you have 2 divided by 2 like 4 times, what's it still going to be? Just 1. So what was our rule here? Have we figured that out, a shortcut on these? Yeah, I think if you look back at the top 2, it's much easier to tell. So if you got 2 to the 8th over 2 to the 3rd, if we do 8 minus 3, what do you get? 5. So if we did, the next one is 5 and 3. So 5 minus 3 is 2. So every time they're just subtracting the exponents, right? So I'm going to write our rule over here. If we've got x to the m over x to the n, what is that going to be? What did we say we do with our exponents? So m minus n. Is that okay? So that's our rule when you're dividing terms with like bases. So I would highlight those. That's what we're going to need in a minute. I want to go back to the middle 2 right here. So on this one, if we do 6 minus 7, what is that? So this should be like 5 to the negative 1. Is that what we wrote? So we're going to come back to that in a second. We want to know, are these two the same thing? Question mark. So we're going to put this to the side and come back to it. Remind me later, okay? And then what about the next one? If we subtract your exponents there, what is 4 minus 4? 0. So that would be like 2 to the 0. Yeah? Is that what we wrote? So we need to come back to that one as well too. So those are like strange cases that we're going to get back to and see what's going on here. I want to finish this section. So we're looking at the next part. So it says the negative exponent rule. We've got 2 to the negative 3. And then what in the world? How did they get over here? What changed from that first box to that middle box? So if it had a negative exponent, they pulled it to the bottom, yeah? And then to the next part, they just figured out what 2 to the third was, because that's 2 times 2 times 2. So 2 times 2 is 4, times 2 again gives you 8. That's where that 1/8 came from. Is that okay? So if we're looking at the next one, we've got 3 to the negative 2. So how are we going to get that, like what are we going to do with that negative exponent? Negative positive, move it to the bottom. So we've got 1 over 3 squared now, because you're going to move it and you're going to change the sign to a positive. So then we could simplify a little bit further, and what is 3 squared? 9, so that would be like 1 over 9 there. Then looking at the next one, so this is kind of backwards. It's 1 over 2 to the negative 3. So what do y'all think we would need to do with that? We can't really move it to the bottom because it's already in the bottom. What do you think? Yeah, move it to the top. So we'll have 2 to the third. And what is 2 to the third? 8. The one after that, we've got 1 over 3 to the negative 2. So again, if your negative is already in the denominator, where are you going to move it to? To the top. So that would just be like 3 squared now. And what is 3 squared? 9. So what is our rule for negative exponents? How could we write that? Instead of x to the negative m, what are we going to have? 1 over x to the m. Is that all right? Questions so far? Okay. So a lot of that you may have seen in middle school. Is any of this familiar at all? Maybe a little bit? Okay. So yeah, that's all your bell ringer stuff. So can we go back to this one right here. So 5 to the negative 1. Is that the same thing as 1 over 5? We've got a negative exponent. What did you say you do with negative exponents? Move it to the bottom. So we're moving that 5 to the bottom, and it's like 5 to the 1, which is just 5. So are these two things the same? Yes. So we're good to go there. I'm going to put a little check mark there because we're all good. The only one we don't know yet is the 0. So we're still going to put a push pin in that. We're going to come back to it. So don't forget that one. We got 2 to the 0. We got to figure out if that is the same thing as 1. So I want us to move to your graphic organizer now, which is this page that you picked up on the way in. So a bunch of this, we already know what to fill in now because we just did it on the bell ringer. So the first thing that you got is just reminding you how to add and subtract monomials. So that's like one term. So you just combine your like terms. So do y'all remember what makes something like terms? Same exponent, same variable. So if we are combining these two, are they like terms? We got 9 x squared y minus 10 x squared y. Same variable, same exponent? Yes. So what is 9 minus 10? So that whole thing is just negative 1 x squared y squared. Nothing changes with your variables, nothing changes with your exponents, correct? So if you are just adding or subtracting, combine like terms, that's all. We know how to do that. We've been doing that since day 1 in this class. Yeah? So looking at the next part there, it says subtract 6w from 8w. So we've got to write that out first before we can do anything. So if it says subtract 6w from 8w, how do you write that? Do we do 6w minus 8w? Or 8w minus 6w? It says subtract 6w from 8w. So that's kind of like a flip. You got to switch the order. So 8w minus 6w. Then we can combine those like terms, right? And what is 8 minus 6? 2. So that whole thing is 2w. Is that all right? So just refreshing your skills on combining like terms. Easy peasy, yeah? Okay, so the next part is your product rule. So if you are multiplying terms with like bases, what do we do with our exponents? We just talked about this. Product rule, if you're multiplying terms with like bases, we added. So this time our exponents are a and b, so we'll say that is x to the a plus b. So if we're looking over here, we've got h squared times h to the 6th. Do they have the same base? Yep, so we're going to keep that base of h. And what do you do with your exponents? Add them. So 2 plus 6 gives us 8. Is that okay? Alright, so looking at the next one, we got a bunch of stuff going on. You've got negative 2a squared b times 7a cubed b. So we're going to keep all the same things together. So negative 2 and 7 are both just like regular numbers, right? So if they're being multiplied, we're just going to multiply them like regular numbers. What is negative 2 times 7? Negative 14. So then we got to treat the variables kind of like terms, where we're only going to take things with the same basis. So we're just looking at our a's right now, and they're being multiplied. So what do you do with your exponents? Add them, right, as we're doing over here. So if you've got a squared times a to the 3rd, add your exponents. What is 2 plus 3? 5, so that's like a to the 5th. Then we've still got to deal with our b's. So we've got a b times another b. What would that be? B what? To the 2nd? We have that b squared, yeah? We just added 1 plus 1 there. That gave us b squared. Questions so far? Alright, so the next one, this is your power rule. So if you have a power to a power, what do you do? So everybody, now if you have a power to a power, what do you do? I'm not kidding, everybody, arms up, let's go, let's go. A power to a power, you multiply. So how are we going to write this? X to the what? AB. So then we're going to apply that over here. So if we've got x squared to the 3rd, multiply your exponents. What is 2 times 3? 6. That's going to be x to the 6th. Is that alright? So the next one there's a little bit trickier. So we've got everything inside these parentheses is being squared. So we're going to do each part individually. So that negative 2 squared. What is negative 2 times negative 2? 4. Positive 4. So we're going to have a 4. Then we've got m to the 5th squared. So again, a power to a power, you multiply. So 5 times 2 gives you 10. So we need an m to the 10 there. All that is still times m to the 3rd. So at this point, we're going to have 4 times like 1. That's in front of that m to the 3rd, right? So just 4. And then we've got m to the 10th times n to the 3rd. So when you're multiplying terms with like bases, what do you do with your exponents? Add them this time. So 10 plus 3 is going to give us 13. Questions there? Alright. So the next part is talking about your quotient rule. So if you're dividing terms with like bases, what do we do? And we wrote it on your bell ringer. Subtract. So we're going to write x to the what? A minus b. So if we're looking over here, we need to simplify the big numbers first. So 27 over 42. What will that reduce to? Anything? Somebody type it in a calculator real quick. What do you get? Nine over 14. So we got a 9 on top, 14 on the bottom. Okay? We're just reducing that fraction. Then we've got x to the 5th over x. So what do we have to do with our exponents on your dividing terms with like bases? Subtract, just like we said over here. So this is like 5 minus 1. And what is 5 minus 1? So that's like x to the 4th. Is that okay? They may also write that like 9 over 14 and have the x to the fourth off to the side. They're both the exact same thing. Questions on that one? Yeah. Yep, because like our regular rules for math still apply with that 27 and 42. So we just divided those. It doesn't go evenly, so we write it in the simplest fraction. Yeah. And then just subtract your exponents. Is that okay? All right, so the next one there, we're going to have to handle the top first. What's going on in your numerator there? Everything is being squared. So we've got a power to a power. What do? Multiply. So what is 2 times 2? 4. So that's really like y to the what? 4th over y to the 4th. So now that we're just dividing, what do you do with your exponents when you're dividing terms with like bases? Subtract. So what is 4 minus 4? 0. So we've got y to the 0. Which is what? She says it's 1. What do y'all think? Somebody grab a calculator. Pick a number, any number. 3. Type 3 to the 0. In your calculator right now. Everybody, put hands on your calculator. Type it in. Tell me what you get. We get 1. Okay, pick another number. Any number. 74 to the 0 power. What do you get? 1. Pick another number. Any number. I heard 108. I don't know if I'm making that up or if y'all said that. But 108 to the 0 power. What do you get? 1. So what if we have 1,000,007 to the 0 power? What are you going to get? 1. If I have negative 582 to the 0 power, what are you going to get? If I have elephants to the 0 power, what are you going to get? 1. Anything to the 0 power is going to give you what? 1. So anything to the 0 power is going to give you what, Michael? Anything to the 0 power is going to give you what? 1. 1. Anything to the 0 power is going to give you what? 1. Is that okay? Yeah? No? Maybe? So can we go back to the bell ringer for just a second? So that one where we had 2 to the 0, is that the same thing as 1? Yes. So we were all good on that one. So again, anything to the 0 power is going to give you what? 1. We are almost done here. So your negative exponent rules. If you've got a negative exponent, how did we handle that? We just move it to the bottom. Once you move it, it's not negative anymore. So we're going to have 1 over x to the positive a. Is that okay? So let's do that over here. So that negative 5, it's just a regular number, negative 5, where you're going to leave it on top of your fraction and not do anything with it. Then when you've got x to the negative 2, you have to move that to the bottom. And once you move it, is it still negative? Nope, so that's just x squared. So we've got negative 5 over x squared. Looking at the next one, we've got regular numbers 4 and 8. So 4 over 8, will that reduce or simplify? Or divide out evenly? 1/2. So we know we're going to have the fraction 1/2. And then we've got k squared over k to the 5th. What do you do with your exponents? If you're dividing terms with like bases, you subtract your exponents. So 2 minus 5, what do you get? So we've got k to the negative 3 there. And what do you do with negative exponents? Move it to the bottom. So we've got 1 over 2 k to the 3rd. Is that okay? Yes, maybe? Questions on that? Alright, so then your notes now should be super, super, super easy because we just went through all the hard stuff now. So I would keep this handy if you're still memorizing those rules, and we're going to write them over and over again and apply them over and over again in your notes. So yeah, we're just going to jump on in. Is that okay with y'all? Better be. So at the top, we're going to review just a little bit of vocabulary, which we've already been using. So if you've got this expression, x to the 4th, what's the exponent there? 4. And what's the base? x. That's like your big number. Your base is your big number, which those are things that I've been saying this time as we've been going through it all. So your base is the big number at the bottom, and your exponent is your little number. So if it wants us to evaluate 5 squared, what is that? What does 5 squared mean? 5 times 5, and what is 5 times 5? 25. Then it wants us to evaluate 4 to the third. So what is that? I just need a pass. 3 fingers. 4 to the third. What does that mean? 4 times 4 times 4. And what is that? What's 4 times 4? And 16 times 4 gives you 64. Is that okay? Last thing we got, it says, what does x to the fourth mean? X times what? Awesome, great, fantastic, cool. I'm glad he left. X to the fourth, x times x times x times x, yes? I'm gonna get you some Lysol. That alright? Yeah? You okay? Alright. So then the next part is product rule again. So we've already done this. If you are multiplying terms with like bases, what do you do with your exponents? Add them. So this is going to be a to the what? M plus n. So when you do something together, are you ready to try some on your own? Pick 2. Which one do y'all want to do? 1 and 7. Alright, so p to the 4th times p to the 8th. What do you do with your exponents? Add them. What's 4 plus 8? 12. So that's just p to the 12th. Is that okay? Alright, then we said 7. So we've got a squared times a to the x. What do we do with our exponents? Add them. So what is 2 plus x? 2 plus x. Is that okay? Can we also look at number 8 real quick while we're here? So for 8, what is the exponent on that y? 1. They don't write it, but it's there, yeah? So that's like x to the 1 times y to the c. So if you're multiplying terms with like bases, what do you do with your exponents? Add them. So we're adding 1 plus c, which is what? 1 plus c. Is that okay? I think we did all the hard ones together. So y'all okay to finish those other ones real quick? I'm going to give you 30 seconds. Yeah. Alright, so Sonia, what'd you get for number 2? C to the 13th. Y'all agree? Questions there? Great. Megan, what'd you get for number 3? V8. Should have had a V8. Is that okay? Questions on that? Alright, and number 4, Keelan, what'd you get? You got it. W to the 74. Jacob, what'd you get for number 5? E to the 13. And last one, number 6, Noah, what'd you get?
X.
You got it. X to the C plus D. Questions on any of those? So we're okay? Easy? Okay. So the next one, you got a power to a power. What do you do? Multiply. So this is going to be a to the what? mn. So pick two. Which ones y'all want to do? 1 and 7. Sounds good to me. 6 and 7? Okay. So we're doing 6. Everything inside those parentheses has to get squared. So you've got to do d to the 5th squared. So when you've got 5 or d to the 5th squared again, that's going to be like to the 5th to the 2nd, power to a power, multiply 5 times 2. What do you get? D to the 10th. I've made that way too complicated. Just multiply your exponents for everything. That's all. Just square it all. So d to the 5th squared is going to be d to the 10th. Then we've got e to the 6th squared. So multiply 6 times 2, 12. So that's going to be e to the 12th. Is that okay? Are we sure? I don't even know what I said the first time. I'm sorry. So if we look at number 7, again, everything is getting squared. So it's kind of like distributing in the fact that everything's got to get that exponent of 2. So if you have 3 squared, what is that? 9. Then we've got y to the 8th squared. So that power to a power, what do you have to do? Multiply. So 8 times 2 gives you 16, y to the 16th there. Is that okay? Do we need to do another one? 8? Do you want to do 8? Okay. So again, everything inside those parentheses is getting that exponent. So we're going to do 5 to the 3rd, x to the 3rd, w to the 7th to the 3rd, or that's a y to the 7th, and a z to the 4th to the 3rd. If we do 5 to the 3rd, that's 5 times 5 times 5. What's 5 times 5? 25 times 5 again, 125. Then you got x to the 3rd. Oh, what's that? Just x to the 3rd. Then we've got y to the 7th to the 3rd. So power to a power, multiply your exponents. What is 7 times 3? So that's going to be y to the 21. Is that okay? Alright, and then the last part there, z to the 4th to the 3rd. So power to a power with your exponents there. What's 4 times 3? 12. So that's going to be z to the 12th. Is that alright? Yes, no, maybe? Yes? Okay. Do we need to do another one? Okay, try the rest of them on your own. They're much easier. We did all the hard ones. Alright, can we go over these now? Do we have enough time to get those done? Yeah? Okay, so looking at number 1, we've got x to the 4th to the 5th. Bailey, what is that? It's a power to a power, so what do you have to do with your exponents? Multiply, so 4 times 5 gives you 'Is that okay? Yeah? Questions? Alright, so number 2, Natalie, what'd you get? M to the 21. Where did the 21 come from, y'all? 7 times 3. Sierra, what'd you get for number 3? So 2 to the 6, where did that 6 come from? 2 times 3, power to power, you gotta multiply, yeah. You could figure out what 2 to the 6th is if you want to. Did anybody do that by chance? Chloe, did you? No. What is it? That's when they were separate. So like down here, we just had a 3 squared, so we just did 3 squared 9. Like there wasn't an exponent on that 3. You multiply the exponents and then figure out what it is. So like we're doing 2 to the 2nd to the 3rd. So we did 2 times 3, so it's all going to be 2 to the 6th. And then you could type that in your calculator, figure out what that number is if you wanted to. That's 64 if you're interested. Does that make any sense? So if the number has an exponent on it, then you got to do power to a power first. If it doesn't have an exponent on it, then just do whatever power. So square it or cube it or whatever. Does that make any sense? Do we have any other questions right now? Okay. So for number 4, Catherine, what'd you get? Okay, so what do we do with our exponents? If it's a power to a power, what do you do? Multiply. So you're just multiplying a times 3.
So it would just be
X to the, what's a times 3?
8.
A times 3. 3a. That all right? Questions on that? Anybody else still confused there? So the next one's the exact same thing. So Haley, what do we get for number 5? For 9p. Is that okay? Questions there? Anything we're not sure about, don't quite understand? Alrighty. So the next part is basically what we were already doing on like 7 and 8. So it's the product to a power. So everything inside the parentheses has to get that exponent. So then we would have a to the n, and also b to the n. So you're just giving everything inside those parentheses that exponent. So let's pick, do y'all just want to go through all these together? We just do that. So for the first one, you've got ab to the 4th. So everything's got to get that exponent of 4. So how are we going to write that? A to the 4th, b to the 4th. So then what about number 2? Everything inside those parentheses is getting that exponent of 2. So how do we write it? 5 squared x squared. Can we simplify that a little bit and say what 5 squared actually is? What is 5 squared? 25. So we've got 25x squared there. Is that all right? So looking at number 3, everything inside parentheses is getting that exponent of 3. So is the 2 going to get raised to the 3rd? Yeah. So we'll have 2 to the 3rd. What about the b? So b to the 3rd. And what about the c? So c to the 3rd. And we could clean that up a little bit more as well. What is 2 to the 3rd? What's 2 times 2? Times 2 again? 8. So 8 b to the 3rd, c to the 3rd. Okay? Alrighty, so number 4. How do you think we'd write that one, y'all? B to the n, c to the n. Yeah? Alright, last one, number 5. How are we going to write that? 8 to the x. What else? B to the x. And that's it. Is that okay? Alright. So the next part is talking about your quotient rule. We have already just talked about that. No, just kidding. Quotient to a power rule. So everything inside your parentheses again has to get that exponent. So this is just going to be like a to the n over b to the n. So basically the exact same thing that we just did with the product to a power rule. Yeah, more of the same. So we'll just go through these together as well. So for that first one, how would we rewrite that? You got c over d all to the 8th. C to the 8th over d to the 8th. Is that okay? What about number 2? 4 to the 3rd over h to the 3rd. Are y'all okay to just leave that as 4 to the 3rd? Yeah, we could multiply it out, but I ran out of room, so. Is it okay if we just don't? What about number 3? What would that one be? 2 to the 4th over 3 to the 4th. What would number 4 be? P to the e over k to the e. And then last one, number 5. What would that one be? So 5 squared, like 25, I'm going to write that. And then c squared. And then what's on the bottom? 7 squared or 49? Questions on any of those? Not too bad, right? No response. Cool. So the next part, this is your quotient rule before that we were talking about. So when you're dividing terms with like bases, what do you do with your exponents? What do we do before? You're dividing terms with like bases, what do you do with your exponents? Subtract. So this is going to be a to the what? M minus n. So when dividing terms with like bases, you will subtract S-U-B-T-R-A-C-T. So we are going to do that on these. Do we need to do some together? Pick a couple. 6? 4, 5, 6. Sounds good to me. So for number 4, we're going to subtract our exponents. What is 420 minus 20? So that's just b to the 400. Is that okay? Alright, what about number 5? It's kind of like formatted badly, but that should just be x to the a over x to the b. So just x minus, or x to the a minus b. We're just subtracting those exponents, and since they aren't like terms, they're not like real numbers that we can actually subtract, so we'll just leave it as a minus b. For number 6, we've got v to the c, but then on the bottom, they didn't write an exponent. What do we know is there? 1. So when we subtract this, you're going to do c minus what? 1. So you'll have v to the c minus 1. Is that okay? Can y'all do the rest? So what's wrong with 7? 2 different what? So they have different bases. So can we simplify that? There's nothing you can do with it, just leave it the same. Our rules only apply when your bases are the same. Since we've got a base of x in the numerator, a base of y in the denominator, there's nothing you can do there. Is that okay? Alright, so 1, 2, and 3, y'all doing them on your own? All right, so for number 1, Abigail, what'd you get? Where'd that 3 come from, y'all? 7 minus 4. Good. Rylan, what'd you get for number 2? W to the 2 or W squared. And where did that 2 come from, y'all? 3 minus 1. They don't write it, but it's there. And then last one, Joe, what'd you get for number 3? So n to the 5th. Is that okay? Questions? All right, cool. So the next part is talking about our zero exponents, which we've already done this. So the first part wants you to expand. So if you've got n to the 5th, how many times are you writing n? 5 times. So 1, 2, 3, 4, 5. And then same thing on the bottom, n to the 5th again. So write n 5 times. And then we cancel what we can, right? And those cancel, those cancel, those cancel, those cancel, those cancel. Everything cancels out. What are we left with? 1. The second part there wants you to use your exponent rules. So like we were just doing, if you have terms with like bases and you're dividing, you subtract your exponents. So what is 5 minus 5? 0. So n to the 5 minus 5 is n to the 0. And we know that anything to the 0 gives us 1. So a to the 0 is going to be 1. B to the 0 is going to be what? If we had b to the 0, what would it be? 1. C to the 0 would be? D to the 0 would be? Anything to the 0 is going to be? Yes. Is that okay? So the only exception is if that, like, a equals 0. So we'll say except when a equals 0. And that's just going to be like 0 to a 0, so it's undefined. So any base to the 0 power will equal 1. So h to the 0, what's that going to be? What about 9 to the 0? 54 to the 0. What about 6 y to the 0? Is it 6 to the 0 power? What's to the 0 power there? Just y, right? So that's like 6 times y to the 0. And what is y to the 0? So what is 6 times 1? Is that okay? Number 5, what's different? So what does those parentheses tell us? Everything gets that exponent of 0. So if everything is to the 0 power, what's that going to be? 1. They will trick you every time with these two. So be very, very careful and pay close attention to what's going on there, what actually has the exponent, okay? Looking at number 6, that's negative x to the 0. So that's really like negative 1 times x to the 0. And what is x to the 0? 1. So negative 1 times 1 gives you negative 1. Is that okay? Questions? What about number 7? Everything's to the 0. So is it still going to be negative 1 or will it be positive 1 now? Positive 1. The only reason we had negative 1 on number 6 was because that negative hanging out front. Okay? Questions? All right. So for our negative exponents, we've already talked about those. So if you've got a to the negative n, what do we do with that? Put it on the bottom. So do y'all know that song that's like, I like to move it, move it. I like to move it. That one? I always think of that when I do this one. So you got to move it, and then you got to change it, change it. So we're going to move it to the bottom, and then you're going to change it because it's not negative anymore. So we're going to move it to the bottom and make it a positive n. So a can't be 0 here because that would make us divide by 0, and that's not right. But yeah, so you're going to move it, you're going to change it, change it. Is that okay? Pick a couple for us to do together. 11 and 8. We'll do those two. Do me a favor, mark out number 15 right now. You don't have to do that one. So so we're looking at 8 and 11. So if we look at number 8, we've got x to the third, y to the negative 2, and z to the fifth. Do we have any like bases there? So there's nothing we can do with like combining stuff or simplifying in that way. But we do have one negative exponent on our y. So what do you do with negative exponents? You gotta move it. You gotta change it. So we're gonna have y squared on the bottom, yeah? Because we're gonna move it, we're gonna change it so it's not negative anymore. And then what was left on top? That x to the third and z to the fifth. We didn't do anything with them, so they're still just hanging out up there. And that's all we can do on that one. Questions? Can we do we'll do 11 and then we're going to do number 5. So looking at 11, all this stuff is being multiplied, yeah? So what do you do with your exponents when you have like terms that are being multiplied? Or like bases that are being multiplied? Add them. So we're going to add 8 plus negative 2. What is that? 6 plus 0. 6 plus 1. 7. So all this is just b to the 7th. Is that okay? Alright, last one we're going to do together. Number 5. We've got 5 c to the negative 4. So what do you do with negative exponents? Move it to the bottom. So what are we moving to the bottom? Just c to the 4. What do you do with the top? Or the 5. Leave it on the top. Sorry, I kind of gave that away. You leave the 5 on the top, move the c to the 4th to the bottom. So we move it and we change it so it's not negative anymore. Is that alright? Questions? Can y'all do the rest on your own? Yeah?